Okay, so a recent study found that the life expectancy of a people, maybe of a person, living in Africa is normally distributed with an average of 53 years with a standard deviation of 7.5 years. If a person in Africa is selected at random, what is the probability that the person will die before the age of 65? Okay, so this is a normally distributed situation here. So that means I can model this situation using that's a rough normal distribution, but okay. And on a normal distribution, the mean is right here in the center. So the mean here is 53 years, the average of 53 years. And I can go up 1 standard deviation, 2 standard deviations, 3 standard deviations. I can go down 1 standard deviation, 2 standard deviations, and 3. So the mean is 53, right? The mean is 53. And the standard deviation is 7.5. So if I add 1 standard deviation, that'll be what? 60.5. If I add another 7.5, that'll be 68. If I add another 7.5, that'll be what? 75.5. Yeah, is that right? Let's just double check, make sure I'm not going crazy here. 53 plus 7.5 plus 7.5 plus 7.5. Cool, going in the other direction, I can minus 7.5 and then minus another 7.5. And then minus another. Oh, I did divide it by. Why does that look like that? 45.5 minus 7.5 minus 7.5. Right, so if we were asked for the probability that a person will die before or after one of these values, that would work very well for us, because in this normal distribution, we know that 68% of the values are 1 standard deviation away. So there's 68% of the values are in here. We also know that, let me change that line a little bit. Hey, what's going on here? We also know that 95% of the values are 2 standard deviations away from our mean. And finally, we know that 99% of the values, give or take some decimal places, are 3 standard deviations away from our mean. It would be an easier question to answer if we were right on one of these values. But we're not. We're asked about 65, which is somewhere around here maybe. We're asked about 65. And I don't know the exact probability there. So what we'll need is the standard normal distribution. That's what we'll need to answer this question. There's a way to do this in the calculator. I'm not going to show that just because, So we need the standard normal distribution, which operates on z values, not these x values here. So on the standard normal distribution, the mean is in the center, is 0, and then each standard deviation is 1. Right? So we need to have a means to convert this x value, specifically this one is 65, right? That x value of 65, what we're interested in. We need to convert that to a z value, which will be somewhere in here. It'll be 1 point something, but we need to know exactly what it is. Let's check our formula sheet. See if we have a formula for that. We do. The standard score, z equals the x value minus the mean divided by the standard deviation. So that's the formula we're going to use to convert x value minus the mean divided by the standard deviation. And we have those values. We have the x value that we're interested in, 65. We know the mean is 53. And we know the standard deviation is 7.5. I'll do this in the calculator. We have 65 minus 53. Come on, give me, what in the world? Shift. Is my shift key not working? Like that. What in the world? Okay. I forgot. You've got to do it on the calculator. My bad. Divided by 7.5. So that's 1.6, just like we thought, right? It's 1 point something. So this is 1.6. Okay, so that's this x value here equates to a z value of 1.6. Why is that important? Because I can find these funny values, these in-between values. I can find these probabilities for z values. I can't do them for x values. So we want the probability that the person will die before the age of 45. We want this percentage or this probability here. We want this area, less than, which is the same on the standard normal distribution. We want less than. I'm not coloring within the lines. I'm ignoring the first rule of coloring. Okay. So here we wanted the probability that x is less than 65, which is the same as the probability that z is less than 1.6. They're the same thing. We're asking for the same thing here. The areas are the same. To find this, and as a result to find that, go back to my formula sheet. Now I'm going to go down to the z distribution tables. Here's the standard normal distribution tables here. Now what this tells us is, look, if I look for the z value, it tells me the area to the left. That's for the negative z values. And the next page is for positive z values. See? If I tell z, it'll give me the area to the left of that z value. It'll give me the probability less than that z value. What's our z? 1.6. So I come here on the right, I look for 1.6, just 1.60. If it was 1.61, I would go over here, 1.62, 3, 4, 5, 6, 7, 8, 9. We just want 1.60. That's my probability. That's my area to the left. That's also the probability less than 0.9452. And that's our answer. So answer 0.9452. If I wanted the area to the probability to the right, the total area underneath this curve, underneath either of these curves, is 1. So if I got the area to the left, I could just subtract that from 1, and I would get the area to the right. If it asked me for greater than or after the age of 65. But as it stands, here's our answer. 0.9452.